Good morning. I'm Sivagar. I'm from Google. I'm the tech lead for the DC stack, and that's Nick.
Yeah, I'm Nick Fotopoulos. I'm a manager at Google. So we're a little different than the usual crowd who comes to OCP. We are the team that enables our server teams to work with the vendors and actually produce all the servers. So maybe it's a little different point of view than you usually hear. So Google makes a lot of servers. It used to be, as everyone knows, that you could just lift the performance of all of your workloads by just waiting a year and build the next server. No problem. But now that that has really slowed down, if you really want to take a workload that you really care about and give it the double-digit % lift, you need to specialize. And that can take the form of build a custom hardware accelerator. Google has been publishing a lot about its video transcoder units, its TPUs, and more recently, its infrastructure processing units as well. Or a different form of that could be, specialize the machine shape. So maybe you just really, really care about your data latency and need to just have an ultra huge memory machine. So in this sort of Cambrian explosion of server types, Google realized that we can't design and build everything ourselves. That's inefficient. We don't really want to do that. And so the obvious solution presents itself is, take advantage of all these really, really smart people out there. Let's just buy something or co-design with them. Historically, though, there was a lot of friction. It has been slow to engage partners sometimes with proprietary everything. It's very hard to reproduce. It's really hard to get the agreements right to share everything. And every problem is an opportunity. I believe it. So we differentiate where it matters. And for everything else, let's adopt a standard. Or where there's not a standard, let's develop one with the community. And this lets us interoperate. It lets us really, impedance match with our vendors. And enable us to buy something that someone else has already developed for us. So that leads us to DC Stack. So DC Stack is the interface between us and our vendors. It's also a philosophy for how we design our servers. And where we can, we really do try to use OCP official solutions. Maybe not all of them are fully there, but we're getting there, and we really buy into the open system firmware. OpenBMC is now everywhere. OCP diags is something that I believe we developed and then worked with OCP to make a standard, and we're really excited about that. That we're just converting all the way there. Where OCP doesn't give us a standard, we try to use other standards. Redfish is an example, totally behind that. And then open source, Linux being the most obvious one, both the kernel and the distro. But that said, when we build our servers, we know that people have secret sauce. People want to differentiate. People, really invest in their own thing. Both we do, Google, and so do all of our partners. And so our software stack, we made design from the beginning to really layer these elegantly. Both, the management of the code and also the, producing an image from all these. They stack very nicely. And this is all, of course, on the backdrop of the open hardware standards that you find folks are putting together. With that, let me hand over to Sivagar. He's going to tell you a little bit more concretely what these abstract principles have led us to.
Yeah, thank you. Jack can hold it. Yeah, so if you attend the morning sessions, right, let's say from the SDC issues, even like what Dongwei talked about, the system ready, everywhere you find there is one common thing, like when we want to work with a vendor or work with somebody else, like multiple co-development, then we always lack is like a common environment to run. So that's the main thing we want to solve here, basically. So if you look at the D1 DC-MHS, like we have all this modular hardware system, but how we can actually validate that it actually has the right feature we need for the data center. So that's the main thing we want to solve. So what does that mean, basically, is like we want an environment, common environment, where we can create tools and also run diags so that we can validate the feature. So that's where we start. So our base is like, goal is here is to run the manufacturing test and tools, right, for us right now. But this can be used for every other thing, all the collaboration with vendors. Like even I can imagine like in SDC, if we want to work with academic partners or different people, so we can use this common environment where we can have this common distro and then have manufacturing DAX run over it, because we do have a set of features. So for example, like why we have BMC bias here is like, actually Dongwei mentioned it multiple times in the previous talk, right? So even when they have the system ready, they do find some problem with open BMC missing, right? So that's the things like when we realized we need a common environment to run DIACs, there are certain basic things we need from the firmware. So we adopt, like Nick mentioned in the previous slide, we adopt OSF. That's our BIOS solution here. So we didn't say which one, EDK to Linux boot, everything, right? Because here it's like OSF based BIOS. And the BMC, we are adopting the Open BMC. And over that, we have this Linux distro. And you can actually, we just say Linux distro. You can choose what you want. But in this environment right now, we are using some standard ones. We work with vendors and others. Over that, we have the manufacturing test and tools, DIACs basically based on OCP DIAC, which it's part of the OCP. And that's the common stack. So now we have this common stack to develop. But what's the next step? So how we can make sure that it's actually work, right? So that's where the next stage comes in, where we co-develop with vendors and also have a common, what we call continuous integration and deployment, right? Right now, we are using our own internal CI/CD system, continuous integration and continuous deployment, right? But we are working with some third-party vendors. I let Nick finish that one in the next slide, to make it open, actually. So what does that mean is, so you have all these tools. Let's say you work with a CPU vendor. They have certain tools and DIACs running on this. Now, it's running on this common platform. So now we work with the JDM with all the previous, the things Nick talked about in the previous slide with different layers. So we can work with them. Now the JDM can actually use what the CPU vendors created, right? The DIACs, maybe it's something to do with the SDC, it's something to do with, or maybe a DIM manufacturer. They have some different way of testing the DIMMs, right? They wrote the DIACs. Now it can be interoperable. Directly you can use with your JDM. So that's the things we want. But again, the CI/CD, what it does is, now the same platform, let's say common platform, it can be any open platform or it can be a newer platform you're building, can be run at a CPU vendor, DIM vendor, and you. It's all in the same environment, so you can see how the things are connected, right? If one is tested, you can run the same thing at the JDM side. And recently, we even found that for us to repeat a problem when we power on a system or something, it almost takes 3 weeks to reproduce the same environment with the CPU vendor, right? But recently, we had a problem. We just fixed it in 2 days, and then actually get the code immediately deployed and then tested it out. So this actually works. So right now, this is, like I said, Google's server SDK, right? So it's closed right now. We are working with multiple partners, 18 plus, I think, right now. But our aim is to get this stable, and then probably next year come to this, make it more open so that we can work with other hyperscalers and see the scope, like how much we can leverage, and then make it as a part of OCP at a later stage. So that's our goal on this one. Anything I missed in this slide? No. Okay. So why we are here, basically. So we are tested this, and we are working with 18 plus vendors right now and partners, basically. So next year, like I said, we are going to have it hyperscale partners on board and try it out in a different environment. But again, the use cases, what we have in mind might not be the same as what you have in mind, right? So that's why please talk to us so that we can, when we are ready for the next year, we will be having a common spec and common standards for everybody to work with. So in 2 years, we are trying to get to the industry standard level. Nick.
That's the end of our talk. I don't know if we have time for questions or we want to advance the schedule. Thanks.
Wonderful presentation. Now, would you tell us how you're working with the rest of the community to propagate DCA stack so other people can participate as well?
Well, as we've sort of admitted here, so far it has largely been us and Google and Google's vendors. We have been reaching out to a few partners to sort of understand their needs and look at what demos we could do with them, what proof of concept. And what we're finding is that other hyperscalers really do have the same sorts of problems, the reproducibility, the awkward tools friction. And so I think our initial indication is that we're solving the right problems, and we really hope that in talking to you today, we can find out more of which directions we need to evolve.
Very good. So basically, this is engineering to engineering discussion at OCP. It seems that you're asking people to come and help, right?
Let's start by talking. Unfortunately, we're not able to release our parts of the code today.
So I can add a little bit to it, right? So for example, one of the main thing is like we can talk about all this DC-MHS and all the different modules, and even like Dongwei said about system ready, there are certain MIE specifications and other things. But what we want as partners is like, let's say we have a spec. So we want have all the spec associated with DIACs, right? So that's one of the things we want. So when we talk about even creating a spec, shall we come up with a test specification associated with the spec? So that will be actually very helpful for us. So let's say if the test is associated with OCP DIACs from the day one. So now we can actually leverage that going forward. So that's the kind of thing we want as partners, basically. So when we talk about something in SDC, so shall we create the DIACs in OCP DIAC? So if we say, let's say system ready, so we have the MIE specification. So can we have all this associated with OCP DIACs? Then that will be the one we will be utilizing it so that it's easier for us. Let's say you have new motherboard or anything, right? So we can actually validate that much easily, work with different partners.
Very good. So it seems that it's possible to connect things with system ready, perhaps. We have test and validation work group at OCP. Who is part of test and validation? So perhaps a good collaboration can eventually happen, make this one real, right?
That is correct, yeah.
Very good. Thank you.
Thank you.